Hi, Conf42 viewers, and welcome to this SRE 2024 session about creating Terraform providers and my journey when I wanted to create one, starting from learning the documentation up until publishing it into the Terraform registry. We'll cover a bit about a refresher about what is infrastructure as code, and then discuss where should we start and how to create a provider, including a live demo. I'm Harel Safra. I'm a data platform engineering team lead at Riskified. Riskified is a fraud detection company centered around e-commerce solutions. And my team manages all the online databases that are part of our systems. We use SQL, NoSQL, search engines, graph databases to provide our services. Before that, I've been in the infrastructure domain for 20 plus years, managing servers, network switches, storage databases, and anything to that effect. What is infrastructure as code? Infrastructure as code is a programmatic definition of infrastructure elements. That means that we want to define infrastructure, which could be various things like servers and network switches, but it could also be database users or Elasticsearch indexes, in a programmatic way that allows for repeatable and documented processes where the knowledge is baked into the process itself and doesn't depend on humans remembering what they need to do. There are two general approaches for infrastructure as code. The first one is declarative. We ask the users to define what they want to achieve. And the framework compiles that into infrastructure elements. You can think of Terraform in that domain. The other approach is imperative. The user defines how they want to achieve something. It's more of a code-based approach. And the framework, again, creates an infrastructure for the user. You can think of Pulumi in that domain. Terraform providers are the plugins that interface with the infrastructure API on one side, and they also interface with the Terraform core over RPC on the other side, and they bridge the gap between what Terraform core is and what the infrastructure needs on the API to create the infrastructure elements. There are 4,100 plus published providers as of this recording. And the main point is that anyone can create more providers. You don't have to associate with the infrastructure vendor itself. Anyone can create a provider as long as there's a valid API that you can work with. You need to understand a bit about the architecture first. The first element is Terraform core, which is actually the Terraform executable that runs when you run a Terraform command. If you run Terraform plan, it actually runs Terraform core in the documentation's language. Terraform core will communicate over RPC with a Terraform provider. And the Terraform provider uses native calls inside the process to communicate with a client library that then communicates over the native infrastructure APIs and protocol with the infrastructure itself to provision resources. And this native library, this native communication can happen on HTTP. You'll find it in various documentation. But it could also be gRPC or SQL or system calls or anything that the infrastructure knows how to interpret. So obviously, the first thing you need to understand is the API that's supported by your infrastructure. Find the correct API to interface with that, and find an easy way to do that. If there's an existing golang client for your infrastructure, try and use that. It will probably be easiest. Otherwise, you have to reverse engineer the protocol, and that can be a bit annoying. After you understood the API, you should learn Go. Go is the language that the Terraform providers are written in. It's a compiled high-level programming language. And you need to understand Go. You don't need to understand Go too deeply, but you need to understand control structures and a bit about interfaces and how you go about creating code. I use a step-by-step tutorial that's found in the Go site, go.dev/tour, and it's a good tutorial. It will take you from not knowing Go to have a working knowledge about how to use it. I like Go for its simplicity. It's easy to understand and to learn. I like very much that it's compiled. Like compilers find problems before you do it in production. There's one thing that you need to remember: there's no exception if you or use the exception handling for other languages. That you have to check method return values for errors, and otherwise you'll find that your code will error out for various reasons because you didn't check the written error. So you understand the API, you have a working knowledge of Go. Now you need to understand how to create the providers. I used HashiCorp's documentation to learn how to do that. It's located in the developer portal under Terraform plugins. You don't need to learn everything in advance. Just read the overview and then continue from there in the sections you need. You have after you have the basics, let's see how you create the provider itself. We'll use a demo of a provider that manages lines inside the text file. It's a simple made-up example, but it will allow you to understand what we do. All the files are managed in a single path that's defined in the provider configuration. Well, there's a single type of resource, a file, that has a file name and a lines array, and it's actually just an array of strings, nothing too fancy. The file API that provided is limited and limited by design because when you're working with other types of APIs, there will be limitations that you need to understand and work around, and you didn't just want to provide an API that allows you to do everything on files. An example for this, for our recent configuration, you can see on the left, there's a file1 resource that has file name equals file1 and lines line 1 and line 2. And the provider will translate it into a text file containing line 1 and line 2 named file1. Clone the code under my GitHub repository, Safra/Terraform provider file data. And it's also published in the Terraform registry for you to see. After you understood the API that you work on, you're in the documentation, the documentation will point you to creating providers with a plugin framework. And this is actually the correct way and the recommended way to create new providers. It abstracts a lot of interactions that need to happen with Terraform core and allows you to focus on your logic. You start by cloning the Terraform provider scaffolding framework repo to your GitHub repository, GitHub profile, and then you can tweak it and customize it from there. Terraform providers have four basic operations that they need to support for each managed resource. And these operations both provision the infrastructure itself, or change the infrastructure, or delete the infrastructure, but they also amend the Terraform state, or actually they provide the instructions for Terraform core to amend the Terraform state after they've done the operation. So after a create operation, you need to amend the state so that the state will include the new resource that was created. A create operation obviously provisions the new resource. A read operation gets the infrastructure's current state. That means that it will go and read the infrastructure state of the API and return that into Terraform core. An update operation changes attributes that can be changed. And obviously not every attribute in the infrastructure can be changed. And a delete operation removes the resource. Terraform core sometimes uses a delete operation to change resources that cannot be changed. If there's an immutable attribute, Terraform core will destroy and recreate the resource to change that attribute. If you look at the code, this is how the repository works. When you clone the repository, we will have a documentation directory, and all the other code sits in the internal provider and the resources. So if we look at the file resource, it has a few different methods that cover the operations. It has the delete operation. The delete method covers the delete operation, update, read, and create. And if you look inside one of the methods, you can see they all start with the same kind of way. You start by getting the parameters that Terraform core has sent to the provider, and then you do a bit of logic, and then you return a response to Terraform core to allow it to amend the state correctly. So if you take, for example, the create operation, you can see this provider starts with creating a full name from the base path inside the provider, and then from the file name provided inside the create operation. And then it iterates over all the lines inside the lines array and writes them to the file with the API.writeLine operation. Schemas and attributes are used to map between Terraform configuration files and the code itself. So every configuration block of the provider, either the resource or the provider itself, has a schema that define the needed parameters. And schemas contain attributes that define the data elements itself. Each attribute has a type. It could be a primitive, like an x64 or a string, and it could also be a complex type, like a map, an object, a list. Each attribute also has properties, like a description, if it's optional, if it's sensitive, or other attributes, other properties. And it can have optional validators that check the user's supplied values and against what the provider expects, and allows you to not check them later on because they will fail the validation checks. If you look at back to the code, you can see that the file resource has a schema method that defines the schema that the file resource expects to receive. It starts with a description of the file resource itself, and then has an attribute named file name, which is of type string. It has a description file name, it's required, obviously, and it has a validator that checks the correctness of the file name provided. In this example, with the regex. It also has a lines attribute, which is a list attribute. A list attribute, a list in Terraform is a collection of elements of the same type. This is also required. And the element type is string, as I mentioned earlier. And it has a validator that's a list validator that requires the list to have at least 2 elements inside it. Just as an example, nothing too fancy about it. Try these descriptions wherever you can, because these descriptions are later on grabbed by the documentation framework to create these lovely documentation files. And you can see the description is copied from here and every other attribute. So if you have the descriptions inside your resource file, it will be copied to the documentation, and you can use that to publish your provider later on. Types of the Terraform plugin framework are not native Golang types. So an Int64 in the plugin framework is not a native Int64 because they have additional methods to handle null values and unknown values. For example, an Int64 and any other type has an isNull method that returns a true or false in case this is a null value or not. When you want to access the values, you use in case of it's a primitive type, you use the value type method, like value Int64, that returns a native Int64. If it's a collection, you can convert the values into Golang types with the as methods. For example, list has an elements as a method that returns the type as a native Go type. If we look at the code, again, inside the file resources, you can see that, over the breakpoint, you can see that the same create method is accessed the file name attribute, which is a string attribute with value.string. It's used in various other places. So this value string will copy the framework type into a native type and convert it into a string that you can work with. After you created your code, the code runs, at least hopefully. You probably want to run it locally and debug it in case there are errors. The first thing that you can use to run Terraform providers locally is to use a tfc-like config file with a provider installation dev overrides substanza, which translate a registry address into a local address that has your code. This will allow you to run the code without publishing it into Terraform registry. You can use log-based debugging for simple cases, but for more complex cases, use debugger-based debugging. It will allow you to set breakpoints and run your code as any other code. You do that by passing a flag dash dash debug equals true. You set an environment variable that it outputs, and then you run your action that you want to run, and it will break inside the provider code. Let's see an example for that in action. We're starting with a configuration directory. We have a configuration directory that has a provider file that defines a base path. And this base path is the same as the one we're currently in. It also has a resources file that defines two files, and file2 with these names, and the line inside them. And we can see that if we get file2, you'll see the lines AA, BBB, and CCC, the same as the provider has defined them. If we run Terraform plan now, there's no changes because the resources have the same values as the infrastructure. Say you want to debug the plan state, and specifically you want to debug the read operation inside the Terraform plan. We'll start by setting a breakpoint inside the read method of the provider. Then we'll make sure the run configuration has a dash dash debug equals true as a program argument. And we click the debug button. And it will instruct us to copy these values and set them as an environment variable. And this will allow the core executable to reconnect to that running session, not just use what it has in this directory. So we export this value. And if you run Terraform plan again now, you will see that the debugger has jumped and started to run, and it breaks inside the read method. And from here, you can just use the regular debugging operation to debug your code and see what happens. In this case, you can see that this is the read operation for file2. And if we resume running the code, there will be another break for the read operation of file1. And while this is running, the Terraform process is hanging. It's actually waiting for instruction that are returned from the provider. And if we resume the operation, it will continue and, in this case, again, show that there are no changes. So that's how you debug operations. Use it. It's very powerful. It's very easy to debug like that. After we created the code, we debugged it. It seems to be working. Add acceptance tests. It will be used both for automatic tests during deploys inside GitHub Actions, but you can also use it locally to make sure that your changes are valid and you didn't break anything. You can have automatic testing for resources, data sources, providers, and anything that you created. The state inside the acceptance test is checked implicitly. You don't have to check that the state changes are done correctly. But if you do have any change that you want to validate on the infrastructure side, you need to do that inside the acceptance test. You can run it manually, all the test suite manually with make test act. And the way you structure that is you have a file resource, the resource name underscore test inside the same directory. So if we take a look at the code, you can see that the file resource has a file resource underscore test file. And it has a function called, and each function is actually a test. So you can have multiple functions for test. And there's a helper function here that defines the files that need to be run. So you can see there's a configuration block for provider and another configuration block for a resource name of type file data with this name that gets passed inside as a parameter here and has the lines formatted as lines here. And this allows you to use the same kind of configuration block for different tests. You can see, that, for example, that in this test, I passed file 1 with 1 and 2 in the lines. And in this case, the test and update, I passed the same file name, but with 2 and 3. And this allows the same configuration method to create different configuration files to allow you to test. The check, you have to define each check to pass, and this is just a check that tests the resource attribute. It tests the file name is indeed equal to file 1. This check is a bit more interesting because it tests that lines, the first line, the first value in lines is equal to 2, as we defined here. As I said, you can run the configuration, the acceptance tests, both inside the operation, and you can also run it by running make test act that will just run the acceptance test, and we can just run it again and again to make sure that everything that we created and changed is indeed valid. It didn't break any other functionality. After you finish creating a provider, you debugged it, it looked working, you created test acceptance tests and all passing. You can publish into the Terraform registry and allow other people to use your work. You first define a GPG key, and then set the repo secret GPG private key and passphrase to your values. An important thing that it took me some time to understand is that you need to create a tag named v version, for example, v0.1.0, to allow the automation to grab the changes. And after you created the tag and pushed it into GitHub, you can log into Terraform registry and add the repo. For the initial load, Terraform will read what the current contents of the repo, but it will also set webhooks that push any new changes to Terraform registry. And new changes are new tags. So if you have a tag named v1, and then you push a new tag named v2, there's a default GitHub action that will compile that into resources. And then Terraform registry will go and grab these resources and publish it. You can see that in this example, I have the version is 0.1.0, and it's backed by a tag named v0.1.0. So to wrap it up, my journey with the provider started with no provider, just manual management, scripts, manual work procedures, a lot of documentation and conflicts. I started by learning Go and the Terraform framework. I then created code for the provider and released more features. In my example, I created a provider that defines users and sets inside the Aerospike database. That's something that wasn't available. After the code was created, I published it into the Terraform registry, and people appear to be using it. Thank you for your time today. If you have any questions, feel free to reach out to me either by my email or by my LinkedIn profile, or open an issue on the provider that's published under GitHub /Safra. Thank you, and I hope it's been instructing for you.